In this video, we're going to walk through a few solutions to some practice problems. We're going to look at electron configurations and orbital diagrams. And we're going to start with nickel. Nickel is going to be in our fourth period of the periodic table. And so we'll start with an abbreviation using argon in the third period to abbreviate the electron configuration up to that noble gas. And then we'll build from there. And so for argon, we're going to have our two 4s electrons, and then we get into our 3d orbitals, and we'll have 8 of those. Now looking at its electron configuration, or sorry, its orbital diagram, we could build this up from 1s, right? We could also start at 4s if we wanted. For this one, we'll start at the bottom. So we have 1s orbitals, then 2s, then we have 2p, then we have our 3s orbitals, then our 3p orbitals. Followed then, instead of our 3d, we go to our 4s orbitals, and then our 3d. And so filling up from the bottom, we'll have everything filled up until our 3d orbitals. Remember, we always half fill our orbitals first, and then we pair up our electrons. And so for our 3d orbital, we have 8. So I'll fill everything up with 1 electron. That's 5, 6, 7, 8. So we'll have 2 unpaired electrons in our 3d orbital. And so this is our energy diagram, or our orbital diagram. And this is our abbreviated electron configuration. So now let's turn our attention to copper. Looking at the periodic table, it's in the same row as nickel, so I can abbreviate again with argon, and I'll then build up from that. So I'll still have my 4s2, and then looking at where copper comes in our periodic table, if you have yours out with you, it's in the ninth electron has been placed in the d orbitals. So it'll be 3d9 for our abbreviated electron configuration. Now, this is one of those exception points where we're looking at an electron configuration where we're just 1 electron away from filling our d orbitals. And so it's actually favorable for us to see that s electron promote itself into the d orbital to completely fill it. And so the actual electron configuration for copper is just 1 electron in the s orbital and 3d10. And so when we do this for our diagram, we can we'll show that with the full d electrons. And so that will have an impact on copper's behavior as it has that electronic environment that is much closer to something that isn't a transition metal. So I'm going to do an abbreviated orbital diagram here, since we'll have this part be exactly the same for both nickel and for copper. So I'll pick up at my 4s orbitals and then my 3d. So I've got 1 electron in my 4s, and then I start filling in my 3d, and I'll have 10. So these will all be paired, leaving me with that unpaired electron actually in the valence shell at a lower energy level. All right, so that's copper. Let's now move on to get a little practice with an ion. We have technetium +2. So looking at the periodic table, this comes in a different period. So for our abbreviated electron configuration, I'm going to start with the noble gas krypton and build from there. And from there, we'll have our 2 5s electrons, followed by our 5d electrons. So it'll be 4d5. And this one is now going to have, so this would be for technetium on its own. The +2 means we have to remove 2 of our electrons. But where do we remove them from? Well, we're always going to remove first from the valence shell. And so it's the 5s electrons that are in the valence shell. We know that because 5 is our largest n value in our electron configuration. So I'll remove those 2 electrons and have a electron configuration for technetium plus 2 ion that's just 4d5. If I want to draw the orbital diagram for that, I am going to do an abbreviated version again, where I'll have my 5s right here and my 4d. I'm going to leave my 4s or 5s blank, and I'm going to put in my 5 electrons in my 4d orbitals on my orbital diagram.